6 years after America put a man on the moon, the red planet was next. As the world swung into the 1970s, NASA turned its attention to Mars. The United States had found a new frontier for exploration with the help of NASA Langley in this edition of History Through the Lens. Hello, I'm Tom Schaad. Welcome to this edition of History Through the Lens. We often say a conversation like this is not rocket science. Well, no, it is in this case. We're talking about the 50th anniversary of the Viking mission to Mars. And it started in 1975 and, of course, went over a course of a couple of years to 1976 as well. And NASA Langley played such a huge role in the success of that mission to Mars. So I am joined by a man who was there, Dr. Joel S. Levine. He's a research professor now at the College of William and Mary of the Department of Applied Science, and he was a former senior research scientist at NASA and really had an instrumental role on the Viking project. So let's go back to the year 1975, and in terms of NASA and what they were doing at that time, the Apollo missions of the moon were winding down, and the country was in a different place. You know, we were pulling out of Vietnam. We had lots of issues with our economy, and there was a lot of pessimism in the country at that point. What was the atmosphere at NASA when you were there, and including NASA Langley when you went into the Viking mission?
Well, after the successful landing of the first humans on Mars, NASA was looking for new...
Oh, you mean the moon?
I'm sorry.
I just want to say moon,
yes.
Yeah.
After the successful landing of humans on the moon in 1969, NASA was looking for other things to do, and what emerged was sending a spacecraft to actually land on the surface of Mars, soft land on Mars, and the NASA Langley Research Center in Hampton, Virginia, was given that task by NASA headquarters to develop the mission and to manage the mission. The launch took place in the summer of 1975, and the successful soft landing took place on July 20th, a year later, 1976, with Viking Lander 1 successfully soft landing on Mars and became the first spacecraft to be operational and successful on the surface of another planet, successfully send data back to Earth and continue the investigation.
Now, what did that mean in 1975, 76 in that era? We talk about sending data back to Earth. It's something we take for granted today, almost.
Well, Mars is out there. Mars is a very interesting place, and NASA decided that we should actually land on the planet, soft land. What's interesting is that the United States achieved that successfully in 1976, and it wasn't until 3 years ago that another country, the Republic of China, successfully landed on Mars with an operational and functioning spacecraft, 47 years after the United States first did it, and has done it several times. China became just the second country to achieve that accomplishment.
So NASA Langley itself and the country at that time, can you just give us a sense of where NASA was at that point?
Well, NASA was coming off a major accomplishment, landing the first two humans on the surface of the moon. And I think it showed the how good American science, technology, engineering was to achieve the lunar landing, and then again a few years later to achieve the first successful soft landing of a spacecraft on another planet.
We got some really good film from NASA Langley on this. I know you were talking about this earlier, Dr. Levine. This is a supersonic parachute?
Yes, it turns out when the spacecraft, the Viking spacecraft, the Viking consisted of an orbiting spacecraft and a lander.
Mm-hmm.
The lander was part of the orbiting spacecraft. And on radio command, the lander was released in something called an aeroshell. It traveled through the atmosphere of Mars and successfully landed on the surface. When it was released from the orbiter, it was traveling 13,000 miles an hour.
Wow.
13,000 miles an hour. And 7 minutes later, in order to land successfully, it would have to be going about 4 or 5 miles an hour, or else there would be another crater, a new crater on the surface of Mars due to the impact of the spacecraft. But we were able to successfully soft land by a series of mechanisms to slow the motion down. First, a supersonic parachute was deployed.
Wow.
It was 50 feet across, developed at NASA Langley Research Center. Then, as it got closer to the surface of Mars, retro rockets, 3 retro rockets slowed it down. And about 7 minutes later, it's traveling about 4 or 5 miles an hour. It successfully landed on the surface of Mars, the first time in the history of the human race that we successfully landed an operational and functioning spacecraft on another planet.
And 1970s technology, too.
1970s technology, and the fact is that it was a major feat of engineering and a major feat of science accomplished by United States of America.
What did we learn from going to Mars at that point? It kind of started a whole new interest in trying to explore other heavenly bodies besides the moon.
Well, basically, it's fair to say that the Viking mission rewrote the book about our knowledge on Mars, and I have right before me a hardbound book. This is a reprint from the Journal of Geophysical Research, which is the major scientific journal. It's 721 pages, and it contains 56 chapters, 56 articles by the 83 Viking scientists dealing with the atmosphere of Mars, the surface of Mars, the evolution of life, and the search for life on Mars. And so literally the Viking mission rewrote the textbook about Mars.
That is a great place right now to take a break. We're going to come back with more on the Viking mission to Mars, 50th anniversary of the launch this summer on History Through the Lens. Almost sounds celestial, doesn't it? That full music.
Yes. It's very appropriate.
We come back through this edition of History Through the Lens. I'm Tom Schaad, and Dr. Joel S. Levine, former senior research scientist at NASA and a very instrumental figure on the Viking missions to Mars, joining us here from the College of William and Mary. You are a research professor at the Department of Applied Science there, and we're happy to have you with us. So it's interesting. For so many years, we were told there is really no life on Mars. And now we're rethinking that. And part of it came from the Viking missions, right?
Yes. It turns out that in the Viking orbiter, the spacecraft that remained orbiting Mars, we got imagery. We have I think something like 50,000 photographs of the surface of Mars. We have measurements of the water vapor distribution of the Mars atmosphere. We have measurements of the energy budget of the atmosphere, all from orbit. Then on radio command from Earth, on July 20th, 1976, the Viking lander was released, traveling through the atmosphere of Mars. As it traveled through the atmosphere of Mars, it made the first measurements of the atmosphere composition, of the structure of the atmosphere. Among other things, we discovered the existence of nitrogen, the gas nitrogen in the atmosphere of Mars, which we didn't know about before. And we also measured what's called the isotopic composition. Atoms have different versions depending on the number of neutrons they have. And in the nucleus of the atom, there's a neutron and a proton, and around the nucleus are electrons. But atoms can have different numbers of neutrons. That's called isotopes of the same element. And by measuring the isotopic composition of the atmosphere of Mars, we learned something very interesting. We learned that over its history, planet Mars lost the bulk of its atmosphere somehow. And that was a major discovery that Viking made by looking at the isotopic composition of Mars. We measured the temperature distribution of the atmosphere, the pressure of the atmosphere as it traversed to the surface. Mm-hmm. The Viking lander had 13 different experiments. Three of the most interesting experiments were the biology experiments that searched for the possibility of life on Mars. Is there life on Mars? A fundamental question in all of science. Is there life outside the Earth? And Viking is the first spacecraft, and to date, the only spacecraft ever launched by any country on our planet to look for active life on Mars. There were 3 experiments, and the results were very interesting because the Viking scientists, before the mission, agreed on what would be a positive result, suggesting there was microorganisms living on Mars today, and what would be a negative result, meaning no evidence for microorganisms on the surface. And of the 3 experiments, 1 gave us a positive result, 2 gave negative results, and it turns out that the Viking senior management, the Viking chief scientist, Gerald Salfin, concluded we don't have evidence to suggest that there's life on Mars because we got the 2 negative experiments. And also another experiment which was searching for the presence of organic molecules. Organic molecules are carbon molecules on the surface of Mars. The experiment to look for organic molecules on the surface of Mars didn't find any, which is very surprising. And why that's very surprising is Earth and Mars were formed 4.6 billion, with a B, billion years ago. And over that time, Mars, the surface of Mars, has been bombarded by meteorites, and meteorites contain organic molecules. And that bothered everyone. Why didn't Viking instruments discover organic molecules on the surface of Mars? And it probably colored the interpretation of the biology experiment, because if there's biology, there'll be organic molecules produced. Well, we had 1 positive response and we had 2 negative responses. So Viking concluded there is no unambiguous reason to think there's life on Mars. But over the last 50 years, people have re-examined the Viking data, the data made in 1976. And recently, an astronomer, a scientist, a microbiologist named Dr. Stephen Benner, who's in Florida, concluded that Viking may have in fact discovered life in 1976. And Dr. Benner developed a model for what the surface of Mars, the life on the surface of Mars, how it looks and how it functions. Now, this is very exciting. It's also very recent. He published this within the last 2 years. We need verification. We need to redo life detection experiments on Mars, because Viking so far was the only spacecraft ever launched from planet Earth to look for life on Mars. So we need confirmation. But it is very exciting that some 50 years after the measurements were made, there is new evidence and suggestion that there in fact may be microbial life on Mars.
Well, this catastrophic loss of the atmosphere that you talk about, I know that I read in your paper, it was likened to the climate change that we're going about here on Earth. Of course, here much slower than this catastrophic, all of a sudden, loss on Mars. Is there any possibility that that could have sustained human life? From the data that you found on Viking or any of the other missions?
We know now that when Mars was formed 4.6 billion years ago, Mars was very different than it is today. Mars, in its early history, had oceans like the Earth has. Mars had a thicker atmosphere, and we know that about 3.8 billion years ago, 800 million years after the Earth was formed, we have geological evidence of the first living systems on Mars, on Earth. The first living systems on Earth are dated back to 800 million years after the planet Earth formed. At that time, Mars was very similar to Earth. Mars had the oceans, Mars had a thick atmosphere, and life originated on Earth. The question is, did it originate on Mars, which looked very similar to the Earth? And that's a very important question. And the new reanalysis of Viking data suggests that there's a chance that it did.
We're going to come back and look at some pictures from the Viking mission and pictures of Mars that are fascinating as we continue to examine these questions that are still with us 50 years after the Viking mission from NASA Langley. Back with more History Through the Lens after this. Back with History Through the Lens. I'm Tom Schaad here with Dr. Joel S. Levine from the College of William and Mary. We're talking about Viking and the mission 50 years ago that began, a mission made possible by NASA Langley. And just want to go back on something that you said in on one of the papers that you wrote. I may have misunderstood that the catastrophic event that happened on Mars, you did not liken that to climate change on the Earth. So I want to make sure that we had that straight, right? Can you just clarify that a little bit?
We think that over its history, Mars lost a large amount of its atmosphere. And once it lost large amounts of its atmosphere, the early oceans Mars had evaporated and disappeared from the surface. And our best guess for what happened on Mars is that Mars lost its planetary magnetic field. In the interior of Mars, when Mars was formed, there was molten iron. Earth still has the molten iron, and as it rotates, it produces a planetary magnetic field that protects the Earth from the Earth's atmosphere, by being swept away from particles that come from the sun, called the solar wind. Now, it may be that once Mars' interior cooled and no longer had molten iron rotating in its center, that Mars did in fact lose its magnetic field and lost the shielding of the atmosphere from solar particles, the solar wind. And
Gotcha.
The interaction of the solar wind with the atmosphere caused atoms or molecules in the atmosphere of Mars to be lost to space. Now on Earth, fortunately, we have a planetary magnetic field. We have a molten core that produces this magnetic field, and the Earth is protected from solar particles called solar wind, which are high-energy protons and electrons that are continuously being emitted from the sun.
Different scenario. I'm really glad you clarified that. But you did also say that we should be concerned with climate change on Earth, though you didn't quite liken it to what happened on Mars.
There is strong evidence that over the last 150 years, the temperature of the Earth has increased by several degrees. And the general opinion is that the increase is due to the buildup of fossil fuels, carbon dioxide, methane, a few other gases, nitrous oxide, in the Earth's atmosphere.
Let's get some photos from that we have from NASA Langley, some simulations and some photos. I know we had some shots from Viking, and it was incredible to see those. I remember as a little kid seeing that for the first time, the orange glow of what was Mars at that point being real and not something out of a movie theater.
One of the important things that the Viking lander discovered is that the atmosphere of Mars, even on a clear day, contains large amounts of aerosols, particles blown up from the surface, blown up by wind into the atmosphere, giving Mars' atmosphere the pinkish orange color that we see on these photographs. And so Mars is the red planet. The surface is oxidized iron, giving it a red color. And the particles that are blown up into the atmosphere are grains of material from the surface. And the atmosphere of Mars shows a pinkish, reddish, orange color as a regular feature. In addition, from time to time, Viking showed that there are very strong dust storms on Mars. There are local dust storms. There are regional dust storms.
And there's the orbiter going off, right?
And there are global dust storms. Yes, that's the Viking 1 launch in summer of 1975 on its 8-month trip to Mars, traveling for about 8 months. For a total distance of about 200 million miles.
Jeez.
That's the Viking spacecraft. You see the solar panels, and enclosed within the spacecraft is the lander, which on radio command, once the spacecraft was in orbit around Mars, on radio command, the release of the lander, which traversed through the atmosphere of Mars and made a soft landing. Interestingly enough,
the simulation, though, right here we're looking at.
We're looking at the simulation. What's interesting is that the landing was supposed to take place on July 4th, 1976, the anniversary of the birth of our country. And for various reasons, the project manager of Viking, James Martin, said, we don't know enough about the landing site to land on July 4th, and it took us another 2 weeks to get the images we needed so we could successfully land.
Was there any pressure to hit that July 4th versus we need more time to make sure that we have a successful mission?
Yes, there was a lot of pressure from officials high up in Washington. James Martin was such a fantastic project manager that now anyone in NASA who wants to become a project manager hears lectures about Jim Martin on his philosophy to be a project manager.
Wow.
And one of the lessons is don't rush a mission. If you're not ready to land, don't land. And Jim Martin actually delayed the landing until we had images. That's Jerry Sullivan, the project scientist,
that's wonderful,
who I worked for directly. But Jim Martin said, we're not going to land until we can have a successful
Got
mission.
The fingers crossed.
And that's Tom Young, who was the mission manager. And here's the successful animation of Viking landing. You see the 3 retro rockets slowing it down.
Wow.
And look at the delight. There was a young...
See, that's priceless to me, seeing the reaction.
That's Jim Martin. That's Tom Young. There was a young scientist who worked on the mission named Carl Sagan, and he was an important contributor to the mission.
Heard that name before.
Yeah, and this is he did a great job. He was on the imaging team and sort of the Viking philosopher. And there were 81 scientists that were picked in national competition. There were 13 experiments, and every one of these experiments worked. The landing, which was very difficult, as evident by no other country having a soft landing of a spacecraft on Mars that functioned and operated. Viking was the first. China was the second country 47 years later. And it was a great tribute to the skill of American engineers and American scientists. And the team, the Viking team, several hundred scientists just did a fantastic job. Someone said that for a successful landing, over 1,000 things have to work to within a fraction of a second accuracy for a successful soft landing, and Viking did it, managed in Hampton, Virginia.
And look at all the technology that has resulted from all those missions over the years, over the decades, over the last century that we take for granted today. Satellite communications, I mean, making this show possible on our app, on our television screens and our phones. And it's been a marvelous, marvelous conversation.
Well, and it's a marvelous accomplishment. And today there are plans that the United States of America will send a human mission to Mars, a crew of 4 people, to actually explore Mars and look for life in person. And I doubt whether we would be planning this human mission to Mars without the Viking mission that we had 50 years ago, because the technology and the engineering that Viking used will be used when the first human mission gets to Mars and lands on Mars.
And it's not too far away, right?
It's not too far away. It can be as early as 2035, which is 10 years.
Wow.
So the legacy of the Viking mission is in scientific data. Again, it rewrote the book about Mars. And second, it established the technology base for all future human missions to Mars and the other planets eventually.
I got to leave it there because we're out of time. That was such a marvelous conversation, and I'm so happy you're able to sum it up for us. There's so much more to talk about with this genre of what NASA did over the years, especially NASA Langley. Dr. Joel S. Levine, my guest for History Through the Lens. Thank you so much for joining us today.
My pleasure to be here.
It was a pleasure having you.
Thank you very much.
And remember, folks, we make history every day. Thank you for joining us.